The oil drop experiment was performed by Robert A. Millikan and Harvey Fletcher in 1909 to measure the elementary electric charge, the charge of the electron. The experiment took place in the Ryerson Physical Laboratory at the University of Chicago. Millikan received the Nobel Prize in Physics in 1923. Robert Millikan, in full Robert Andrews Millikan, he was born on March 22, 1868, Morrison, Illinois, U.S. and died on December 19, 1953, San Marino, California. American physicist honored with the Nobel Prize for Physics in 1923 for his study of the elementary electronic charge and the photoelectric effect. The experiment entailed observing tiny electrically charged droplets of oil located between two parallel metal surfaces, forming the plates of a capacitor. At the start of the experiment, an atomizer sprays a fine mist of oil droplets into the upper portion of the chamber. Under the influence of gravity and air resistance, some of the oil droplets fall through a small hole cut in the top metal plate. When the space between the metal plates is ionized by radiation, X-rays, electrons from the air attach themselves to the falling oil droplets, causing them to acquire a negative charge. A light source, set at right angles to a viewing microscope, illuminates the oil droplets and makes them appear as bright stars while they fall. The amount of voltage needed to suspend a droplet is used along with its mass to determine the overall electric charge on the droplet. The mass of a single charged droplet can be calculated by observing how fast it falls. By adjusting the potential difference, or voltage, between the metal plates, the speed of the droplet's motion can be increased or decreased when the amount of upward electric force equals the known downward gravitational force. The charged droplet remains stationary. Through repeated application of this method, Millikan's experiment was meant to have the drops fall at a constant rate. At this constant rate, the force of gravity on the drop and the force of the electric field on the drop are equal. F up equals F down. When a drop is suspended, its weight mg is exactly equal to the electric force applied QE. The values of E, the applied electric field, m, the mass of a drop, and g, the acceleration due to gravity, are all known values. So you can solve for Q, the charge on the drop. He did the experiment numerous times, each time varying the strength of the X-rays ionizing the air so that different numbers of electrons would jump onto the oil molecules each time. The charge Q on a drop was always a multiple of -1.6 by 10 to 19 coulomb. Thank you for watching my video.